Alright, so my name is Kirtyanand and today I am going to tell you something about how to find or how to simplify simple laws of mechanics given by Newton. Now all of us know that Newton predominantly gave three laws, okay? And if I have to talk about these three laws, let me just quickly run you through those three laws. So Newton gave three laws of motion. Now predominantly if we have to solve questions around these three laws of motions, typically things get quite complicated, and the first law definitely is about inertia. Second law is about acceleration of masses, and the third law is about action and reaction of forces. So if you have to ask me, the second law, the mathematical interpretation of the second law is that any external force which is applied on the system is equivalent to the product of mass and acceleration. That is the mathematical interpretation of the law. Yeah. And most of the problems that you would be solving using this second law, which in fact turns out to be the most important law in the three laws of motion, we sort of try to break down our systems into multiple mini systems, and then we form free body diagrams out of those systems. Now if I have to give an example here very quickly without getting into a lot of complications, which typically is the case, and hence it disrupts the learning experience of students. So we will, just to begin with, take a simple pulley, okay, and we will take a two mass system. This is M1, this is M2. M2 is greater than M1. The pulley is massless pulley, and there is no friction, so it is a frictionless pulley. It's an ideal scenario. I'm assuming that both these masses will be point masses. Yeah. Now the typical the conventional approach of solving this problem is something like this. So we cut it here, this becomes my one system, this becomes my second system, and I will create a FBD. So for example, if I am making an FBD, this is for the mass M2. Yeah. So the force here in the downward direction is M2G, and in the upward direction the force which is surfacing, that is T, which is the tension in the string. Yeah. So I'm assuming that the tension in this is the tension in the string, something like that. Yeah, something like that. Now as you can see that the tension here is pulling it upwards and the mass of the body is pulling it downwards. So now my equation becomes, my net force is actually M2G minus T equal to M2 into, let's say, A is the acceleration. Yeah, so we are assuming that A is the acceleration with which mass M2 is coming down. Similarly, A is the acceleration with which mass M1 is going up. And now we create the free body diagram for mass M1. Yeah, so here we will create that. Okay, and as you can see that the mass, the force downwards is M1G and the tension upwards is T, and since it is moving in this direction, therefore my equation automatically becomes T minus M1G equal to M1A. And now I solve these two problems, so these two linear equations, and T gets cancelled out, and what do I get here is acceleration equal to M2 minus M1 G by M1 plus M2. Okay. So this is the conventional approach, and this is a very simple, the most simple example of a mass pulley system. So now let me highlight this same problem using a different approach altogether. Okay. So again I am creating here what I am calling a same problem, but I will solve it slightly differently. M1 mass is here, M2 is here, okay, and our assumptions remain the same. So since M2 is greater than M1, therefore I note that the motion of this entire system is in this direction, that is clockwise, as you see it on the screen. Alright, now if I take this entire system as a whole, okay, and therefore the tension which was appearing in the previous case will not appear in this particular case, because tension becomes an internal force here, and therefore if I am here, outside this frame of reference, so I am not experiencing or I am not seeing tension as a force at all. So I see two forces, one M1G working in this direction and other M2G working in this direction. Alright, now the motion, the direction of the motion is clockwise, and I am assuming that all the acceleration etc. in this direction will be positive, and anything which is happening in this direction will be negative. Alright, so the net external force on this whole system, it's a very fantastic concept. Net external force will be what? Will be M2G, since this is in this direction, so this is positive, and minus M1G, because M1G force is in this direction, but actually it is against the direction of the motion that we have assumed, and we do not even need to assume, since it is given that M2 is greater than M1, so we know that this will be the direction in which the mass will move. So minus M1G. Okay, again I will reiterate that M1G comes in with the minus sign because the direction of M1G is in the opposite direction of the motion. Alright, so that is my net external force. Now what is the net mass of the system? We already assumed that the pulley is massless. So the net mass of the system is M1 plus M2. So therefore it becomes extremely simple. My acceleration will be nothing but the net force by mass, which is nothing but M2 minus M1G divided by M1 plus M2. So this is a fantastically simple concept which saves you this whole process of going through your writing linear equations, creating free body diagrams like here or like here, and it helps you sort of directly come to the answer. And this is not even a cheat, this is not a cheat. Basically this is a pure concept. It's a pure concept, and therefore you see that this concept is in use here. So you are able to simplify your physics approach to problem by using the same concept but by changing the frame of reference. And this was a method, or let's say this approach I was taught by one of my tutors in Bokaro when I used to study physics with him. His name is Mr. Arun Singh, and he's a fabulous teacher. So I think there's a very fundamental usage of Newton's laws in a slightly different way, which simplifies the issue. If you have more problems and more issues related to mechanics, you can always call me or write me basically at my email ID, which is kirtyanand.nishu@gmail.com. So I look forward to your calls. I look forward to your messages. You can catch up on Google Talk or something like that, or you can just drop me an email. Within 24 hours, I'll try to return your email. Thank you.